Uh, Over very recent years of the use of renewable alternative fuels for internal combustion engines has become increasingly relevant due to both the environmental situation of the planet and the fossil fuel prices throughout the world. Diesel fuel is the most common fuel used in agricultural machinery. Its main alternative being vegetable oil fuel in pure form as well as in the form of various additives. Biofuels production growth average 3%, 54k barrels of oil equivalent per day, less than half of the 10 years average. Growth was led by Brazil, 31k barrels, and Indonesia, 32k barrels. But US output declined by 19k barrels. Growth was weighted towards biodiesel, which grew by 34k barrels, largely by Indonesia. Biodiesel is the dominant fuel in Europe and Asia Pacific, making up 81% and 74% of biodiesel respectively in 2019. While ethanol is the main fuel in North America, 86% of total, and South and Central America, 74%. Biofuels consumption rose by 6%, 100k barrels oil equivalent per day, as with production growth was driven mainly by Brazil, 32%, 32k barrels, most of which was ethanol, and Indonesia, 56k barrels, which was largely biodiesel. At the global level, ethanol made up 63% of biodiesel in 2019. But the share of biodiesel has risen continually. For example, biodiesel's share was 23% in 2009, but rose to 37% last year. Use of vegetable oil-based motor fuel is especially relevant in the light of environmental safety of the engine itself, in terms of reducing the concentration of harmful emission in exhaust gases and efficiency resulting from fuel cost reduction. However, there's still a number of problems that need to be addressed in regards to achieving higher efficiency, particularly than using rapeseed oil. It is necessary to ensure that it is supplied to the diesel cylinders in optimal amounts, its combustion is complete, and all probably of it getting into the engine crankcase is excluded. Another necessity lies in preventing the formation of solid film of rapeseed oil on any of the parts of the fuel system, as well as of carbon formation on the working surface of the combustion chamber and atomizer nozzles. That later leads to a decrease in the effective flow area of the nozzle openings, adversely affecting the overall operation of the fuel equipment. To solve this problem, the authors propose a method and a technical solution for operation a diesel engine using rapeseed oil as the fuel in a biofuel system that allows up to 90% replacement of the diesel fuel with alternative fuel, while preserving the engine's technical characteristics and leaving combustion chamber and atomizer nozzles free of carbon formation. In the test represented here, the team used the D440 engine manufactured by the Altai motor plant for agricultural tractors, combines, and road building machinery. The choice of this engine was conditioned by its wide application in self-propelled agricultural machinery in Russia. Cold pressed rapeseed oil and nanodisperse powder consisting of silicon dioxide, aluminum dioxide, and thermally dispersed acid intercalate graphite with particles averaging 40 nanometers in size at the most were used as the fuel mixture. The fuel mixture was prepared by adding the nanodispersed powder to pour rapeseed oil in the amount between 0.01% and 0.02% of the total volume of the fuel. The mixture being heating to a minimum viscosity temperature 80-90 degrees and stirring. The utmost have design technical documentation for the further implement a method of engine adaptation for biofuel system with fuel heating. Engine adaptation for using rapeseed oil fuel requires an additional rapeseed oil tank, a second low pressure line with fuel heating, and an automatic or manual fuel switching system that utilizes electromagnetic wells, the high pressure fuel pump, electronic sensors, and a system control unit. To determine the amount of rapeseed oil getting into the crankcase, branch tests were performed in idle mode at various engine speeds for 8 hours. Before the test, we heated the engine and subsequently drained the crankcase oil in the course of 3 hours. Then the required volume, 21 liters of mineral oil, was poured into the crankcase in accordance with the manufacturer's recommendations, the Altai motor plant. After 8 hours in idle mode, the crankcase oil was completely drained, also in the course of 3 hours. When the volume of drained motor oil was measured, revealing the presence of rapeseed oil that had gotten into the oil sump by the cylinder walls. Analysis of carbonation formation in the combustion chamber and the atomizer nozzles when using rapeseed oil fuel was based on 60 hours of bench tests performed in cycling step modes, simulating the engine's normal operation condition. In the event of operation solely on diesel fuel, no tests were performed. The atomizer nozzles were weighted on a laboratory scale with a measurement error of 0.2 milligrams after having been completely dried in a multi-purpose heating cabinet at a temperature of 105 degrees. Carbon formation on the working surface of the combustion chambers and pistons were assessed visually. This picture you see carbon formation of on nozzles for 16 hours test. Left side it's rapeseed oil, right side rapeseed oil with non-disperse additive. The test condition for 16 hours it's in cyclic step by step modes simulating the engine operation condition. As can be seen in picture, the non-disperse additive causes carbon formation to peel from the working surface of the nozzles. This table presents the results of assessing carbon formation on atomizer nozzles with the engine using diesel fuel per rapeseed oil and rapeseed oil with a non-disperse additive. This picture shows carbon formation on the ignition side of the combustion chamber, then using pure rapeseed oil, then using rapeseed oil with a non-disperse additive. Carbon formation are particularly absent. Valve plates are also clean. Insignificant carbonization on the head of cylinder 4 can be accounted for by insufficient thickness on the gasket under the nozzle. This picture shows the piston surface with soot trace after working on rapeseed oil left side, as well as after working on rapeseed oil using non-disperse additives at right side. Picture shows insignificant presence of soot. Then assessing it, we found the piston rings had retained. They were elasticity and mobility in the annular grooves. An automated dual fuel digital system provide for installation on unmanned tractors, which are included in the neural network, with which it is possible to analyze and control their work, including their fuel system. Thanks for attention.